Welcome to Red Tech Channel, a new way to learn. So today in CT scan I am discussing about CT generation. This is very essential topic for every radiographer which is study CT scan. So let's begin. CT generation. First generation also known as rotate translate pencil beam. First CT generation were solely made for head scan or you can say brain scan. It is used to rotate translate system with a single X-ray beam. That's why we called as a pencil beam. First generation CT scanner having was made up of two X-ray detector were located opposite side of the patient. This was the first originally EMI unit, first CT scanner. Only two detectors were used which measure transmission of X-ray through patient for two different slices. And in the first generation, the detectors were made up of sodium iodide. It was designed especially for evolution of brain. It is only designed to study of brain or you can say head. It has a tube above and the detector below which moves simultaneously or you can say synchronously. This were the first CT generation was developed, and this is rotate translate pencil beam because it cover only a particular area or you can say short area. Pencil beam, it was only designed for brain. That means no body parts or no other scan can't could not be done by the first generation, mainly only study for brain. And now look about advantage. It allows efficient scatter radiation, means having narrow beam or you can say pencil beam does not or did not allow the scatter radiation more. And the now talk about disadvantage. Scan time for one slice is up to 4 to 5 minutes and the total scan time is 22 to 25 minutes. The given scan time is about brain study because CT generation were only developed for brain study or you can say head study. Complex mechanical motion of rotate translate is also a one of the disadvantage of first CT generation because it is very complex to rotate or translate, and sodium iodide detector does not give huge dynamic range in X-ray intensity and produce afterglow which is reduced by fast scan. This is all about the disadvantages. Mainly we remember the two things: the scan time of the, and it were only developed for evolution of brain, you can say that. Now here you look the diagram of the first CT generation. Above the X-ray tube and below the detector, this is the translate and rotate motion. First translate and rotate, and simultaneously detector also move and the images acquire. Two slices two slices at a single time could be taken in first generation CT. So this is all about first generation. Second generation CT, also known as translate rotate narrow fan beam. It was translate rotate type and having 30 detector in which, and this 30 detector having a fan angle which make a fan angle of 10 degree, and which help in collecting data in large number or you can say better than first generation CT. In this second generation, the data per projection or number is increases, and because of using 30 detector and narrow fan beam which is about 10 degree, the angle making by the narrow fan beam is about 10 degree. And translate rotate narrow fan beam also called. Now if we do compare with this generation to first generation CT, then in first generation at one time two slices are taken, but in this second generation it is multi slices taken at a single time. This mainly difference between first generation and second generation. Now talk about advantage. Advantage is uh, by using more detector, the scan time reduces to 10 seconds and gantry rotate at 30 degree each only 6 times rather than full complete 180-degree movement. Means gantry rotate 30 degree in 6 interval and cover the 180-degree portion, or you can say uh, as compared to in the first generation the gantry movement is 180 degree and so as to complete one rotation, but in this case gantry only move 30 degree but taking 6 rounds to complete 180-degree movement. This is basically the difference between first generation and second generation. Because of using high number of detector, this system were added by, or you can say modification in the first generation is this, that can rotate only 30 degree because of having fan beam also. Now look to disadvantage. In this same disadvantage, sodium iodide afterglow and does not give huge dynamic range in X-ray and intensity, and as number of detector increases the scatter radiation also increases, and as usual, complex mechanical motion of translate and rotate are still exist in the second generation as in the first generation. This is also complex, but the difference is translate, rotate, narrow fan beam and increase same. Now look to the diagram. Here you can see above the X-ray tube and below the detectors, and here you can see the narrow fan beam. Arrow showing in the diagram the fan beam approx 10 degree angle, making an angle of 10 degree, and the whole gantry is moving around 30 degree in 6 round. Means in one round takes 30 degree and in one by one taking 6 round to complete 180 degree of the patient. So and taken one at a single time, multi slice could be taken by this generation, and major disadvantage was increase in scatter radiation. So that's all about second generation CT. Third generation, also known as rotate wide fan beam. So in the third generation CT, the number of detector were used 750 detector. It was very huge number used in the any generation of CT scan. Basically name rotate wide fan beam and rotate system used, in which X-ray tube and detector array both are rotated and X-ray beam is collimated into fan beam. Basically we called it wide fan because the fan angle was about 60 degree, and as compared to in second generation our the fan angle were about 10 degree, and in the third generation fan angle was about 60 degree. So the second generation we call narrow fan beam, and in third generation we use wide fan beam because the angle of the fan angle was greater than second generation. But in case of first generation there is no angle of no fan beam, no, so we call pencil beam. And in this better X-ray collimation used to reduce scatter radiation, and in this both xenon and scintillation crystal were used because the X-ray tube and the detector both are precise alignment through entire motion. They both in a precise alignment, so we used both xenon and scintillation crystal. Basically we should remember in this that wide fan angle was about 60 degree. Now talk about advantage. Patient dose less, and in this xenon detector were used, which is highly directional and effectively reject scatter radiation. And as the number of the detector increases, the scan time is reduced. As we have seen in the second generation, the number of detector increases, the scan time reduced to 10 seconds. and in this no translation motion was required, because in this rotate fan beam used, but in the previous generation we use translate rotate system. In this only rotate system, so there is no use of translation motion. So in this we should remember about the point is xenon detector was used, which is highly directional and reduce scatter radiation. Now look to disadvantage. As we have seen that the number of detector increases, so the expensive machine become CT's machine become expensive and complex electronic circuitry, because number of detector was high and the old circuit will be setting up is very difficult work, and creating more scatter radiation and appearance of ring artifact. Basically the main point is you should remember about the appearance of ring artifact. Question may arise in many examination that in at what generation ring artifact was seen or arises. So the answer is third generation CT. The ring artifact were seen or was arise. This we should be remember of every radiographer. Complex electronic circuitry because of having large number of detector used. So wiring and their connectivity is very hard. So now look to the diagram of third generation CT. Here you above can see the X-ray tube and the below is detector array. As we know that the 750 detector were used in the CT generation, so in this only X-ray tube above you can see below the detector array where 750 detector are fixed. So the both X-ray tube and the detector array moved around the patient. In the X-rays are coming in the wide fan beam approx 60-degree angle, and when emitting from X-rays absorbed by detector array. And in third generation you must know about the ring artifact. This was the major disadvantage, and advantage is xenon detector were used. So this is all about CT's third generation. I hope you clear out all the points. CT generation. Fourth generation CT, basically known as stationary. Fourth generation CT designed to overcome the ring artifact which is seen in the third generation CT. I have discussed in my previous video. You can watch this. The link is given in the description. In the fourth generation CT, there is a huge number of detectors were used, more than third generation. In the fourth generation, 4,800 detectors were used. It uses rotate only motion and X-ray tube rotated, but all the detectors are fixed in a circular ring shape structure. Means the detectors are all, means 4008 detectors are fixed in a circular ring shape, only X-ray tube are moving. X-ray tube rotate in a circle inside detector ring, and X-ray beam was collimated to form a fan beam. X-ray beam making a, or you can say collimated a fan beam, and the all detector are fixed in a ring. When X-ray tube emit X-rays, they penetrate the patient and absorbed by the detectors array which are fixed in a circular ring. So we must remember about that in the fourth generation, this generation were developed to overcome the ring artifact, and in this 4800 detector were used and only X-ray tube rotated. Now look to advantages. It was designed to eliminate ring artifact, as I told you earlier. As detector are fixed, single wire connected to detector remain fixed. Means on by using single wire we connect the detector remain in a fixed array, and like no fear of cable wear and tear in case of third generation. As we have seen, disadvantage of third generation is cable wearing and tearing, and scan time reduced as compared to third generation. As I told you, from the first generation that when we increases the number of detector, the scan time basically reduces, because at a single time you can acquire multiple slices. So now look to disadvantage. It increases scatter radiation. Obviously, when you increasing detector, it may increase scatter radiation also, as we have seen in the previous generations. Higher patient dose, because since tube to patient is less, higher patient dose will go through, and expensive due to number of detector was used. Sure, this is common sense that when number of detector were used, the our machine CT machine become expensive and increasing scatter radiation also. Here you can see the fourth generation diagram for CT generation. You can see above the X-ray tube and the making a fan beam, and around it the ring structure where all detector are fixed, so the detector are stationary. You can see here the diagram in detail. Fifth generation. Fifth generation is also known as EBCT, means electron beam CT. CT, this machine was initiative by Emetron for cardiac imaging, basically for cardiac imaging. And EBC consists of waveguide to accelerate an electron into tungsten target through a bending magnet. In this machine, basically there are four tungsten target, so that four slices are imaged at a same time, or you can say four slices could be taken at a single time. EBCD image are produced in as little as 100 milliseconds. So this was the fast scanning machine uh, than previous machines, and this was basically designed, or you can say innovated, or you can say or initiative by Matron for cardiac imaging. Now look to advantages and disadvantages. The major medical advantage of this technology is basically it is used for basically human heart, and this was invented in 1980s, and particularly for imaging of human heart, in which by using this we can detect the coronary calcium score, mainly for detect coronary calcium scoring. And nowadays we seen that in spiral CT we can find out the calcium scoring. So at in the 1980s this machine was invented to rule out or to detect coronary calcium and heart. As you know that heart never stop, so to image the heart we need some fast scanning, or you can say fast scanning machine. So EBCD provided us the fast scanning and the accurate calcium deposit in the arteries also moving, and heart also never stop. So this was the advantage of this machine. And disadvantage is signal to noise ratio and spatial resolution was very not much good as compared to conventional, and give the larger size and low production volume of EBCD. You know that in this machine four tungsten are inbuilt, so it acquire more area than the previous machine. So this is all about the advantage and disadvantage. Main advantage is this for calcium scoring, or you can say cardiac imaging. Now look to the diagram of the EBCD. Now look here, the number one is gun, then focusing coil, then detection deflection coil, and then here you can say on the down you can see here the couch and the whole machine, and it is the in the center you can see here the electron beam is targeting. Here the four tungsten are present, and at a single time four slices could be taken. This machine basically designed to image the heart, or you can say related muscles, to rule out the calcium score in the coronary artery basically. And as you can say four tungsten is inbuilt in this, so This provide very fast scanning than our previous CT generation till fourth generation, or this was invented in 1980. So this is all about fifth generation. I hope you clear out all the points. So do subscribe if you like, and thanks for watching.